Hi, this is Roopa Prasad, Assistant Professor, Department of Computer Applications, MITS College. So today we are going to give present. I am going to give presentation on the topic called as queues. Okay. So first we see what are the contents of this one. So before going to the introduction of queues, first we discuss about the classification of data structures. Then we come for the introduction of queues. Then we discuss the basic operations on queues, and then we go for the implementation of queues, and finally we discuss the algorithm for the queue operations. Okay, so these are the contents which we are going to discuss today. So first, coming to the classification of data structures. So what is a data structure? What do you mean by data structure? Data structure is nothing but the structure of data. That means how the data is organized, how the data is structured, so that the elements are how the elements are stored in the memory, that we call it as a data structure. It is a way of organization. It is a way of organization. There is a structure of data that we call it as a data structure. And coming to the classification of the data structure, this data structures has been classified into two categories. One we call it as a primitive data structure, other one we call it as a non-primitive data structure. Primitive, that we also call it as a built-in data structure, and the another one is called as a non-primitive data structure. Okay, so in this primitive data structure, we have these types. One we call it as integer, and the one is float, character, and pointer. That means what? In this primitive data structure, this particular integer is going to hold one value. It holds the value of an integer. This one will hold the value of a float, and this one is going to hold the value of character, and this holds the address. It is a pointer data structure. Okay, whereas coming to non-primitive data structure, this holds only one. Okay, whereas this non-primitive data structure is going to hold more than one element, So these non-primitive data structures are arrays. Arrays comes under non-primitive data structure. Then coming to list and coming to files. These are called as a non-primitive data structures. Okay, so these data structures hold one data element only, whereas these data structures hold more than one data elements, and these are categorized as arrays, list, and files. Okay, and this list is again divided into two types. List means collection of elements, and this list is again divided into linear data list and non-linear list. Linear list means the data elements are stored in the linear fashion, whereas coming to non-linear means it is going to store the data in the form of non-linear fashion. And this linear list is again divided into stacks and queues, whereas non-linear lists are divided into graphs and trees. Okay, now today in this presentation we are going to discuss about the queues, that is a linear list. We are going to discuss about queues, where it consists the sequence of data elements. It is one of the type of the data structure that we are going to discuss today. Okay, coming to queues introduction. So what we call this queue? We call this queue as first in, first out. Okay, based on the implementation, based on the organization, we are calling this as FIFO. FIFO, that is first in, first out. Okay, so whatever the element we are going to store in the queue first, that element is going to remove first. That is called as a first in, first out. And I think you remember stack is last in, first out. The last, whatever the element we inserted last, that will be removed first. That is called as a stack. That is the nature of stack. Okay, that we call it as a LIFO, whereas this one is called as a FIFO, that is first in, first out. Okay, so what this queue contains? It contains a homogeneous collection of elements. That is, homogeneous means similar. Okay, same data type. Okay, it is going to consist of a same structure, similar collection of elements, in which new elements are added at one end and the existing elements are deleted from other end. That is a peculiarity of queue. Okay, here what happens? New elements are added at one end. Okay, and existing elements are deleted from other end. Okay, where we are adding the element, where we are going to add or insert the elements at the rear position, that end is called as a rear, and from where we are removing, that we call it as a front position. Okay, whereas coming to stack, did you remember? Stack, we are going to insert at only one end and delete from only one end, that we call it as a top. Okay, here we are having two ends. One is called as a rear and one is called as a front. Okay, we are inserting the element of the rear position and we are going to delete the element from the front position. That you have to remember. Insertion will be done at rear and deletion will be done at front. Okay, so from this what we can say, there are two basic operations are there. One we call it as an insert operation and the one is called as a delete operation. These are the basic operations of Q. One is called as insertion and one is called as deletion. So insertion is also called as add operation and deletion operation is also called as remove operation, or we can call it as a push and pop. Insertion is called push and removal is called as pop. And this push operation, push means adding an element, inserting an element. So what it will do, it will insert the element at the rear end, or as we have already discussed, the insertion will be done at the rear, whereas the removal will be done at the front. Insertion is done at rear end and deletion will be, that is removal, pop will be done at the front end. Okay, so if we are implementing Q by using arrays, so what happens, the array index will be incremented at the when we insert an element. Where if you go for the deletion, the index will be decremented. Okay, so that what is the same when implementing using arrays, the total number of elements. So how many elements should be present? Front minus rear plus 1. Front minus rear plus 1. Okay, so coming to this basic operations. So what are the basic operations we have discussed? We have only two operations on the Q can be performed. That we call it as an insertion and second one we call it as a deletion. You have to remember this one. Insertion is done at the rear position. Deletion will be done at the front position. Okay, initially the queue is, look at this diagram. Initially the queue is empty. The queue is empty. No elements are in the queue. No elements are in the queue. So what happens? Insertion is here. What is the rear? What is the index of rear? -1. And what is the index of front? -1. That means what? No element is available in the queue. Okay. Now there is an attempt to insert an element 10. Insert an element 10. So what happens at the insertion? What happens when we insert the element? We are inserting the element at the rear position. So there is only one element. This position is a rear position as well as the front position. Why? Because we have to delete the element from the front only. So what happens? The rear is equal to 0 and front equal to 0. Initially rear equal to -1, front equal to -1. Whenever you are going to insert an element, what happens? Rear becomes 0 and front becomes 0. We are incrementing. Whenever we are going to insert an element, rear will be incremented. This is the first element, so we have to make the front as also 0. Okay, then what is the next thing here? We are going to insert another element. See here, we are going to insert third element. Now what happens whenever insertion is done? Rear will be incremented. Rear will be incremented. Whenever we are deleting, that this has to be decremented. Now what happens? Rear equal to 1. Now here rear equal to 0. One element has been inserted. So what the rear becomes? Rear becomes 1 and front is 0 only. Front is 0 only. So insertion at various positions. Insertion is done at the rear position, whereas the deletion is done at the front position. So now the queue is empty. When the queue is empty, rear equal to -1 and front equal to -1. When we insert the element, then rear becomes 0 and front also becomes 0. First element. Okay. When we insert another element, what happens? Rear will be incremented and front will be as it is. So rear equal to 1 and front equal to 0. Okay. Now see, we are inserting one more element. We are inserting one more element called as 41. So what happens? Rear becomes 2. Rear becomes 2, whereas the front is there only. Then at that position only front will be located. Front equal to 0. Now we have inserted another element called as 70. So in the list we have 10, 3, 41 and recently inserted element is 70. Now the rear position has incremented to 3. Prior it is 2. When we insert another element called as 70, it will be incremented to 3. Front will be 0. Okay, now what happens if you want to delete an element? If you want to delete an element, so deletion is done at the front position. Deletion is done at the front position. As we have seen the peculiarity of Q, what is that one? FIFO. That is first one, first out. First one, first out. So what we are going to do, the first, what the element is inserted first, 10 is inserted, so it has to be removed. So where we are going to remove the element, we are going to remove the element at the front position. We are going to remove the element at the front position. So what happens now? What is a front? 0. Now what happens? Front equal to 1. Front equal to 1. That means what? We are deleting this element. We are not referring this element. Not referring means this element will be deleted. Okay, now that is a deletion process. So whenever we are inserting, rear will be incremented. Whenever we are deleting, front will be incremented. Front will come to the next position. Previously it is 0. Okay, so now when we delete 10, it becomes the front position will move to this particular third element. That is a front equal to 1. Now see here. Now we are, what is the front position? 1. And what is the rear position? 4. Okay, now we are inserting one more element, that is 11. So the front rear becomes 4. Okay, and front is 1. Here only the front will be. Okay, now suppose if you want to delete, we can delete 3. We cannot delete any one element. We can delete only third element. So whatever the element is a front position, that can only be deleted. Deletion is done at one end and insertion will be done at the another end. We can see like this. The elements are inserted like this and the elements are deleted like this. Okay, so we are going to delete the elements like this and we are going to insert the element like this. Now see here. Now we are deleting one more element. So one more element, third is deleted. Now we are deleting 41 also. So what the front becomes 2. When we delete this one, the front becomes 3. Can you understand? So what is the basic thing we have to know means insertion is done at the front rear position, whereas the deletion is done at the front position. So insertion and deletion. Insertion is at the rear position, deletion is at the front position. Okay, now how these cues are implemented? How these cues are implemented? Cues are implemented in two ways. Cues are implemented in two ways. What the example we saw earlier is a array implementation only. Okay, so how the cues are implemented? Cues are implemented in two ways, by using the arrays and by using pointers. Using arrays and using pointers. So if we use arrays, it is a static implementation. It is a static implementation, whereas if we use pointers, that is a linked list, it is called as a dynamic implementation. So what is meant by static and what is meant by dynamic? Static means it does not change. For example, suppose we have allocated an array of 10. An array of 10. That means what? We can able to insert 10 elements only. From that elements only we can able to remove. Okay, only the space allocated for the queue is 10. For the queue is 10 elements only. Okay, so insertion is done at the rear position and deletion is done at the front position. So static, it does not change. Dynamic means what? We can able to increase the element list or we can able to decrease the element list. Okay, at the right time we can able to insert more elements in the queue. That is the difference between the static and dynamic. So static implementation can be done by using the arrays and dynamic implementation can be used by using the pointers. That is a linked list. Okay, so if we try to pop an element from the queue when it is empty, underflow occurs. Same scenario, whatever we have discussed in stack, same also. Whenever we want to delete an element, if the queue is empty and if we try to delete it, call it as underflow. Okay, when the queue is empty, if there is nothing in the queue and still you want to delete, what it means? It is called as underflow. It is called as underflow. Okay, now see static implementation. That is arrays implementation. The size of the queue is 50. The size of the queue is 50 and we have inserted, we have reached up to the 50th position and still if you want to insert one more element, it is called as overflow. Okay, so if there is no element in the queue and if you want to delete, that is called as underflow. If the maximum elements are there and still you want to place it another element, it is called as overflow. These are the two things, underflow versus overflow. Okay, and coming to the algorithms, we just see the implementation of arrays only. So algorithm for the queue operations. So what are the queue operations we have discussed? One is called as insertion and one we call it as a deletion. So we see the algorithm for the insertion. So that the queue is an array to be that queue be the array of specified size, say size. Okay. Now this is array implementation. So what we have discussed, the friend we had insertion is done at the rear position and deletion is done at the front position. So what we are going to initialize means we are going to initialize front equal to 0 and rear equal to -1. Okay. Then we are going to input the value that is to be inserted. Then we are going to check this condition. If rear is greater than or equal to size, rear is greater than or equal to size. Size is a maximum limit. Okay. So rear is greater than or equal to size. Then what is what it means? It means the queue is overflow. That message we are going to display. Okay. As we have already seen, if the elements whatever it reaches the maximum size and still if you want to insert an element, it is called as overflow. That thing we are going to check here. If rear is greater than or equal to size, size is the maximum limit. If it is greater than, then what we are going to say, it is called as overflow, queue overflow, and we are going to exit. If not, that means what? There is a space in the queue. There is a space in the queue. For that purpose, what you are going to do, you are going to just increment rate. Think that the rate is -1, and that means the queue is empty only. So what we are going to do, we are going to insert an element. Before inserting an element, what you are going to do, you are going to increment the rate position. We are going to increment the rate position. So rate becomes 0. Rate becomes 0. That means at the 0th position of the queue, you are going to insert the data what we have taken from the user. Simple algorithm for insertion. So first what we have to do, we have to make initialize. We have to take two variables called as front and rear. Front has to be initialized to 0 and rear has to be initialized to -1. Then we have to input the data that you want to insert in the queue. Then we have to check the condition if the queue is full or not, that is overflow. If it is greater than or equal to size, we are calling it as overflow. If it is not, then what we have to do, we have to increment the rear position, and that incremented position we have to insert the data. Queue of rear equal to data. Data is assigned to this particular location. Queue of 0. That is here in this example, you are placing in the queue of 0. Right. That is the algorithm for insertion. And then coming to the algorithm for deletion, there are only two operations are there in basic operations, insertion and deletion, and this is algorithm for deletion. So here you are taking the queue as an array of specified size called as size. Okay, now here only one thing we have to do. Okay, we have to check if rear is less than front. Rear is less than or front. If rear is less than front. Okay, then what you are going to do, front equal to 0, rear equal to -1, display the queue is empty. The queue is empty and we are going to exit. Okay, that's what we are going to delete the element at the front position. Okay, and this material has been prepared by using this textbook. And if you have any queries, you can give your query to this form. Hope you understand. Thank you.